In this video, we're going to talk about class-based elements. As you might suspect, class-based modeling occurs when you're using classes. And you use classes when you're working in an object-oriented language. The first thing you do when you're trying to identify analysis classes is a grammatical parse of the requirements. Of course, you're looking for nouns here because you want to be able to create objects. Once you have the nouns, they should fall into at least one of these categories if you're going to even consider them for analysis classes. First, external entities that produce or consume information. For example, the safe home security function, the homeowner, or sensors would fall into this category. Next, things that are part of the information domain, like a password or telephone number. Occurrences or events, like a sensor event or an alarm. Roles played by people who interact with the system. The homeowner would again fall into this category. Organizational units, important to the system's operation, like the monitoring service in the safe home example. Places that establish context. And finally, structures that define a class of objects. Sensors might again fall into this category because there can be many kinds of sensors in the system. Once you have a candidate class that falls into at least one of the categories in the previous slide, you want to make sure that those potential classes meet all, or preferably all, of these criteria. You should retain information. Objects have data and operations. If there's no data for them to retain, perhaps they shouldn't be part of your analysis model. They should provide needed services. These are the operations in the class. If a potential class doesn't have needed operations, then it shouldn't be part of the data model. The next one is interesting. The class should have multiple attributes. And by that, Pressman means multiple pieces of data rather than just one piece of data. As an example, a phone number class can be implemented with just an integer. It may be relevant to your system, but it would not be appropriate as an analysis class because it's not abstract enough. It doesn't mean you won't eventually have to implement a telephone number class. It just means that it's not appropriate to represent in your analysis model, where you're trying to get an overall view of the main players in your system. Okay, let's move on. The class should have common attributes and common operations. This means that you can create instances of the class, known as objects, that hold their own data and have their own operations. So, for example, a singleton class, one that produces only one instance or one object, may not be appropriate to represent in an analysis model. The final criteria here, being an essential requirement for the system to function, can sometimes trump all of the other criteria. If a class is essential, then it may go into the analysis model even if it doesn't retain information or is relatively simple or only exists as a singleton object. Okay, now let's go through some concrete examples. We select homeowner as a potential class because the homeowner plays a role in our system and it's an external entity. But we ultimately reject homeowner because it does not retain any useful information, nor does it provide needed services. Think about this. What data would the homeowner hold? Name? Maybe password? Well, maybe that's true if there were several different homeowners logging on from the internet. But from the perspective of the system, there's probably just going to be one password, and anyone with that password would be considered the homeowner. So it's hard to see why you would need a homeowner class. On the other hand, some might argue that the homeowner is such an integral part of the system that it should be treated as an essential requirement. Perhaps. This is a good place to mention that not everyone is going to come up with the same classes. This is an art as much as it is a science. And what Pressman is giving you here are the rules of thumb. So it's possible that reasonable developers may disagree on certain classes. Okay, let's move on. Sensor makes a great class. There are multiple sensor objects created that have various attributes and operations. Control panel is accepted here, but this one might be debatable also. Are we going to spawn multiple control panel objects in our system? Probably not. And if one decides to make homeowner a class, we might not need a control panel class. Installation as a class doesn't seem to merit inclusion in the analysis model. It's just not so specific to our domain. Plus, it's an event that should occur only once. System is accepted, and this is another one I would probably argue about. System just seems too overreaching. You could argue for a system class in almost any project, which makes it seem to me like it's not specific enough to the domain. Okay, so I disagree with Pressman. That's nothing new. Let's move on. The next three classes fail because they're not at a high enough level of abstraction. They're just too simple. It doesn't mean that they won't eventually become classes in our implementation, but they don't belong in the analysis model. The alarm class is interesting because Pressman accepts it even though it does not retain information. It does seem essential to our system though, and certainly it's specific to our domain. I would probably agree with Pressman on this one. Finally, the monitoring service seems too remote from our system to merit that a class be created for it. Okay, I'll leave you with this little taste of what a class in a class diagram looks like. We'll talk a lot more about class diagrams in a future video. There are really two parts to class diagrams. The classes, like the one you see here, which have names, attributes, and operations, and the relationship between the classes, which are represented using different kinds of arrows depending on how any two classes are related to each other. For example, there may be a has-a relationship between two classes, and there may be a is-a relationship between two classes, or there may be just some kind of general dependency. And that's it for this video on the class-based elements of the analysis model. Pressman goes into more detail in his text, but I think what we covered here is the most important aspect of it. In the next video, we'll talk briefly about behavioral elements in the analysis model.